Hello everyone, today let's solve the problem number 211. Design, add and search words data structure. Right? Design, add and search words data structure. So that's what we need to do here, right? So what the question states here, we have to design a data structure. Basically this is a design problem, right? So we have to design a data structure that allows adding the words and searching for words. Just keep this in mind. We have to design a data structure that allows adding words and searching for words, these two things, right? So adding words and searching for words, where searches can contain wildcard characters. So searches can contain wildcard characters, not wildcard characters, basically dot they are speaking of. So dot is the wildcard character basically. So the wildcard matches any letter. It can match any letter they have given in the question. So this is dot, right? Dot or the full stop, whatever you can call. So this one can match any letter. It can match any letter. This is wild card letter they have mentioned in the question, and this can match any letter they have given in the question. Just keep this in mind. This is very important, right? So let's come to the first example here in this case. So we have word dictionary, add word, search here and search, right? So here in this case, just give me a second. Here in this case, word dictionary, we have word dictionary of this thing. So this is the initialization part, and always this one, initialization part, the return value is null. Just remember this one. Means the return value is null. So we get null here. This is fine. So next, let's come to the add word. Add word of bad, right? So add word here, the return value of the add word is null as well. Just keep this in mind. The return value of add word is null as well. Only the return value of search boolean value. Only the return value of the search is boolean value. It can be either true or it can be either false, right? So the return value of the word dictionary function and the return value of the add word is null basically. Only the return value of the search is boolean value. Either it can be true or false. Just remember this one, right? So we are add word we are having. Add word of bad, add word of this one, bad, dad and mad we have. So in this case we have successfully added bad, dad and mad to the try, but the return value still remains the same, null. Return value of this one, I have said this one here. In this case, add word, return value of the add word is null, so it is null. So now let's move on to the next one. Nothing but here in this case, search, right? Search of bad here in this case. First we will search for p, right? First itself it will go false because the character p is not at the this one try, right? Initially ad is present, but initially we have inserted bad, we have added or inserted bad, dad and mad here in this case. So either when we have to search, we have to either search with the word that starts with the letter b, d or m, right? So in this case it is p, it fails miserably here. In this case we have to return false, right? So next let's go with the bad. Search of bad, right? So we have successfully inserted bad already. In this case, search of bad. So we will this one check for b, a and d. We have already inserted b, a, d, right? So this we have to return true in this case. This is true, right? So next we will go with dot ad. Dot means it can match any letter. So here in this case it can match b, the first letter. In this case it can match d, or in this case it can match m as well, right? It can match m as well in this case. So we have to return true in this case. So dot is a wildcard, this one character. It can match any character, right? Wildcard character, and it can match any character in the word. That's what I have said, right? Initially. So let's come to the last one here. B double dot we have. So B, we'll consider this one. This starts with B. Double dot, it can match any character. Dot can match any character. So let's consider dot as A. Let's consider character as dot as D. So this is present in the this one. We have already inserted the bad, right? So we'll consider the same word bad. Now it has to return true in this case. So this is how we got the output: null, false, true, right? So I hope the question is completely clear. What we need to do is completely clear. And also here I have clearly mentioned, so the return value of the word dictionary, the return value of the add word is null, both. So these two functions, the return value of the word dictionary as well as the return value of the add word is null, right? So only the return value of the boolean is return value of the search is boolean. Either it can be true or false. Just keep this in mind, right? So let me delete this one. This is fine. So yeah, now let's do one thing. Let's discuss the approach first, followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the code first. Let's discuss the approach first. So here, first thing that we need to note down here is we will be going with this one, a try plus backtracking approach. So we'll be making use of the try or the prefix tree plus backtracking, right? So just keep this in mind. So I have considered the same example, the first example that they have given for the given in the question, the first example that they have given in the question, right? So let's discuss. So we have already discussed this one, how we got the output, right? By considering the first example, let's move with the step-by-step execution. First thing is adding the words here. In this case, word dictionary of this one is null, right? Word dictionary of this one. Word dictionary. Why this is null? This is the initialization part basically. Word dictionary function. This one is null basically. I have already said this one. Word dictionary and add word. The return value is null. Only for the search we have the return value boolean, right? Just keep this in mind. So let's go with the add word of bad. So add word of dad and add word of mad we have next three, right? So I'll just come here. In this case, we are adding words or we are inserting the words here. What are the words? What are the words that we are inserting here? Bad, 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 dad, dad here in this case, and mad, mad here. This is fine. So we have successfully inserted here bad, dad, and mad. That's what they have asked in the question. Still, this one return value remains null itself for the add word. So here in this case, null, null, null. This is fine. So let's move on with the search part here. Now, search of bad. Search of bad. Let me come here. We are going with the search of bad. The try has no path that is starting with P. Let me come here. Do we have any path here that starts from P? This bad starts from B, dad starts from D, and M starts from M. So we do not have any path that starts with P basically, right? So the try has no path that is starting with P. So what we will do? We will return the boolean value false, right? So this is for the searching. Its return value is either true or false, boolean value, right? So we have to return false in this case. The try has no path starting with P, so we have to return false in this case. So let's come to the next part. Next one here is search of this one, bad. Search of bad. You can clearly see here, man. B is present, A is present, D is present. So search will be successful in this case, right? So search of bad we are doing. We have inserted bad with the notes B, A, D. So B is present, A is present, and D is present within the node, try node. So here in this case, bad exact match is found first itself. So in this case, what we will do? We will return true, right? We have to return true in this case, boolean value true, because the return value of the search is boolean value. Either it can be true or false. So this one we have already went through false. This one is true, right? So next one here is search of this one dot ad. So let's come here, search of dot ad. So dot is a wildcard letter, right? Dot is a wildcard letter which matches, it can match any character or any letter, right? So we have already discussed this one during the question. Multiple times we have discussed this one. You should be knowing by now, right? So dot matches any character. We can consider either B or A or D, because here you can clearly see. So dot, in the place of dot, we can either consider B, we can either consider D, and we can either consider M. So next we have AD for the three words, right? So we can either consider B, we can either consider D or M at the position. And when we consider any character, this basically exists on the try. So we have to return, in this case, we have to return boolean value true, right? This matches basically dot ad. So I hope this is clear. Let me come here. In this case, we have written true, right? So this is fine. Final one is search of B double dot we have, right? So final one is search of B double dot we have. So here in this case, so B is the first, this one, right? So double dot So dot, this matches any character, this matches any character. So in the inserted word, we have the word that starts with B is bad. So double dot we have. We can consider A and we can consider D here in simple terms. Let's consider A, let's consider D, because it can match any character here in this case. So the word is present in the tree. Now we have to return the value, boolean value, true in this case, right? So it matches B. So any means any character here in this case. So we have to return true in this case. Let me come here, just give me a second. So we have written true, right? So now we can come to the conclusion that the output that we got as null, false, true, true, true. And the output that they've given for the question, this one, example 1 is null, false, true, true, true. The output that we got is equivalent to the output that they've given for the first question, right? So approach works absolutely correct in this case. We know this, right? So the approach works absolutely correct in this case. So now we are completely, this is the approach that we'll be basically going with. Just keep this in mind. So now we are completely familiar with the approach. As we are familiar with the approach, let's discuss the edge cases quickly. Let's discuss the edge cases quickly. So I'm considering the same example, the first example that they've given in the question. So here in this case, XYZ. So we had bad. So this one, this example itself, I'm considering basically bad, dad, and mad. So this one, let me come here, mad. So this is fine. So XYZ is not present. Basically, XYZ is not in the tree at all. So in this case, we will return false. This is fine. This is for the edge case, word not in the tree. Word itself is not in the tree. So no single character is present in the tree, basically. Word not in the tree. So here in this case, next edge case is for the single character B. So here, this is false as well, right? So this is false as well. Just give me a second here. Why it is false here? Only bad exists here. Only bad exists. We have to go for search of bad, right? Instead. So only bad exists here. B single character, no. So we'll mark the end of the word, right? So we'll mark the word end of the word. This one, this is fine, this is fine. This one is end, this one is end, this one is end. So this starts with B, no doubt. But we have the word, complete word is bad. Right? In this case also we have to return false. So let's move on with the next edge case, third edge case, full wildcard. So we have dot here. We can either consider bad, we can either consider dad, or we can consider mad here. It doesn't matter. This wildcard, it can match any character, right? So it can be B, bad, dad, or mad. So just for the sake of example, I'll just consider bad here. In this case, we have to return true, right? This is fine. So let's move on with the fourth edge case. No words added here. In this case, we are doing search of bad here in this case. So we haven't, suppose, just for the example's sake, just consider we haven't inserted any word yet. We have not inserted any word yet. Then if we search for bad, obviously we have to go with the output false itself, because we haven't inserted any word, right? To search, first of all, the word has to be present in the try, right? To fetch or search. So bad is not present in the try at all. So in that case, we have to return false, right? So let's come to the final edge case of the fifth edge case here, multiple wildcards. So we have here B dot dot, right? It has to start with B. In our case, we have inserted B, A, D. Let's consider here in this case, this one as A, this one as D. We have already discussed this one in the approach, right? So this one, bad is present, so we'll be returning true in this case, right? So these are the 5 edge cases that we need to keep in mind. So the first edge case is for the word not in the tree. The second edge case is for the single character. The third edge case is for the full wildcard. The fourth edge case is for the no words are added, and the fifth edge case is for the multiple wildcards. These are the 5 edge cases that we need to consider here, right? So just keep this in mind. Now we are completely familiar with the approach as well as the edge cases. As we are completely familiar with the edge cases and approach, now we are good to write the code, right? So let's start writing code. Initially, what I'll do, let's consider the first. Let's consider another try node here. Means another class here named try node. This is fine. So here let's initialize an array for 26 lowercase letters. We'll be making use of only lowercase letters between A to Z, right? So we can initialize the array for 26 lowercase letters. So I'll just go with here try node. So I can write in this way, right? So this one will be children equals new try node of 26. And let's mark this one, mark end of the valid word as this one is end. So I'll just go with here boolean is end. This is fine. So this is it. Next, let's come to the main class word dictionary. In this case, we need the root node of the try, right? For the first letter, we always need the root node of the try, not for the first letter. Basically, we always have the root node for the try. Just remember this one. So I'll just go with private final this one try node. Basically, I'll just give here root. This is fine. So the next step here is initialization part. So we are going with a function word dictionary. Word dictionary, this is initialization part, and the return value is null. We have already discussed this one. We know this one, right? So first root equals new try node. So root, under the root, we got 3 words under the root, right? So first there will be root, and we have got 3 words within the root. First example, nothing but bad, dad, and mad. So first we have initialized the root node. Under the root node, we have 3 things that is stored in the try, nothing but try nodes, right? Bad, dad, and man. These are the 3 words we had stored, right? So in this case, that's what we are initializing the root node here. We are initializing the root to try node, nothing but we are initializing the root node here in this case. So this has to be capital T. Let me change this one very quickly. This is fine. So let's move on with the this one. So just give me a second. Did I miss out anything here? Right. I have initialized final try node. This is fine. Let me format the code once. So this is fine. Yeah. Let's move on with the add word function. Right. So add word, we have to add the word. We have to add the particular word to the try node. Right. So we have to add the particular word to the try. Right. So let me do one thing here. First, let's assign the node to root here. So I'll just go with here and the node to root. This is fine. So the next step here is we will iterate through the word. So we'll be iterating through the individual word here. In this case, char c, this one word to char array. This is fine. This one we are iterating through the word. This is fine. The next step here is we have to get the index of the character. Means getting the index of the character, we have done the same thing in the previous problem as well, if you remember, right? So getting this one, nothing but 0 to 25, right? We can just write in this way, c hyphen a. We are just getting the characters from 0 to 25 as the letters. We have considered the array of size 26 here. Why? We are considering the characters between A to Z, right? From A to Z, not between A to Z, sorry. From A to Z, which is of 25. That is what we are doing here. We are getting the index of that particular character, which we can articulate in the form of code in this way, c hyphen a, right? I hope this is clear. The next step here is after getting the index of the character, if no node exists, then we have to create it. If no node exists, then we have to create it, right? Simple if condition here, if node dot children here, in this case of index, this is equal to null, then what we need to do here? So I'll just give here node dot children of index. We are creating. If no node exists, then we have to create it. I said if no node exists, then we have to create it. Let's create the node then. So here in this case, it is index equals new. I'll just give here try node. So this is fine. The next step after this, we have to move to the next node and we have to mark the end of the word, right? So that's what we have to move to the next node and we have to mark the end of the word. We have discussed this one multiple times in the approach, so this shouldn't be a problem, right? So we just have to articulate the same thing in the form of code here. So I'll just give here node equals node dot children of that particular index within the array. This is fine. So here let me give node dot is end. this one, let me assign this one to the boolean value true. Nothing but we are marking the end of the word, right? So this is it for the add word function. So let me format the code once. So let's come to the this one, search function. So within the search function, let's do one thing. Let's make use of the helper function match, right? So let's make use of the helper function match. For the search function, whatever the characters that we consider, that has to match with the inserted word. And we also have one more condition, that wildcard, if you remember, right? Dot or the wildcard, it matches any character. So while explaining the question, also while during the discussion of the approach as well as the edge cases, we have discussed this one multiple times. Wildcard, these things we have to check. So let's check that one within the, by considering the helper function. I'll just name that one as match, helper function as match, and let's include the helper function within the main function search, right? So let me create the helper function here, private boolean. So let me go with a match here. So this one, let me give string word, this is fine, int index, this is fine. So another parameter I need here, nothing but node, try node. So let's write the code quickly here. The base case, if the node is null, then we have to return false, right? So here, if node, we are comparing, so if node equals null, then let's return false. This was easy. The next step, if we are at the end of the word, then we have to check if it is valid or not. So this is simple. If condition here, if index equals length of the word. So I can just write in this way, dot length. So then we have to return node dot isInt. We are checking the end of the word, right? Check whether it is valid or not. So this is fine. The next step, let's convert this one quickly. So this, I'll just give word dot caret of index. So the next step, if we have to check for the wild character, right? If only the wild character is present, that is also one condition. We have discussed this one. Dot is the wild character. So if character, this is, if it is wild character, or dot, then we have to check all the possible letters, right? So I'll just write simple for loop here, try node. Let me consider the child of node dot children here, children of the node, that particular node, right? So then we have to check for all the possible letters, right? Let me write very simple if condition here, if child not equal to null, and so match, so just give me a second here, match, the same function we are making use of, right? Here we are going with the recur or recursion, right? So I'll just give here word comma index plus 1 here in this case. Also let me make use of the parameter child here. This is fine. So we will check for the all possible letters. If any match is found, then what we'll do, will return true directly. So I'll just go with the boolean value true here, return true. So if no match is found, then we have to return false. Let me come out of this one and let me give here, if no match is found, then we have to return false. This is fine, easy. So else what we will do, else, so we have to move to the next character, else we have to move to the next character. Again, we'll be making use of the recursion here, match, recursive function match, this itself we are making use of, right? So here, so I have already written, this is fine, I have already typed this one. So let me pass the parameters here. So first thing is word, this is fine. So the next one is index, we have, this is fine. So we have to move to the next character, means it will be index plus 1, right? So I hope this is clear. Next thing here is node. So node means we have to move to the next character, means the children of that particular node, right? So we will go with here, let me paste the same thing here, node dot children of, so we have to see whether it matches within the this one particular characters 0 to 25, means there are only 26 characters, right? So within the array, I'll just give here C hyphen A. This is fine. So this is it for the this one, what do you call, helper function match, right? So we have written this one step by step. Let me clean up this one. Just give me a second here. So I hope this is completely clear, easy to understand, right? So now let's make use of the helper function within the main function. So I'll just give here in this case return match of word here. This is fine. 0, this is fine. Root, this is fine. Simple. So let me format the code once and let me hit the run button. So I hope this works. Let's see. What happened here? Children try not. Yeah, this T has to be capital here. Where I have given this one? Line number 2. So yeah, this one, let me make this one capital. So let me run this one again. Let's see. We have one more. Oh, this one has to be char. Actually, I have typed so many typos. Let me come to the line number 16 here. So this one is of the type char. This is fine. So let me hit the run button again. So yeah, now you can clearly see the sample test case is getting passed. Let me hit the submit button quickly. I hope this works for all the test cases. Let's see. I hope this works. Let's see. So yeah, now you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case, right? So let's quickly discuss the complexities for the code that we have written. So let me come here. Just give me a second here. We are discussing the complexities, right? So here, the approach that we went with here is try plus backtracking. We have already discussed this one in the approach, right? So we have already written the code itself. So the approach that we went with here is try plus backtracking, right? So this is fine. So what would be the overall time complexity here? Overall time complexity for the add word function here, in this case, add word function is big O of L per word. So why it is big O of L per word? Because L is nothing but the length of the word here. So overall time complexity would be big O of L itself in this case. So I hope this is clear. So the next one, we have another function here. What is the function name? I forgot. Search, right? So yeah, let me copy this one here. In this case, let me paste it over here. So the time complexity of the search function here is big O of 26 to the power of L. Why it is 26 to the power of L here? Because we are making use of the, in the worst case, first thing, just keep this in mind, we are making use of the wildcard character, nothing but dot here. So in the worst case, big of 26 to the power of L for the dot or for the wildcard character, nothing but L equals word length here. So it would be big of 26 to the power of L, right? I hope this is completely clear, right? So next thing here is, let's discuss the space complexity very quickly here in this case. So try storage is big O of n into n. Here n is nothing but words. We know that one, right? N is nothing but words. So bad, dad, and mad. So in the first example that we considered, that's what we are speaking of here. N is nothing but words. L is nothing but average length. Average length of the word we are considering here. So the try storage would be here big of n into L. Nothing but the overall space complexity would be big of n into L in this case, right? I hope the complexities are clear. So the time complexities for the time complexity for the add word function is big of L, and the search function is this one, big of 26 to the power of L, right? And the space complexity is big of n into L, right? I hope the complexities are clear, and I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching.